So thank you if you're here. This is just going to be a kind of not a quick run through, but I want to go through every single problem. I want to go through uh, all the important notes, and then I kind of just want to give you another chance to look at another practice test. Okay. The practice test that I'm about to do is not the one I gave you in class. It's a generated version, and that can be found in On Campus. Okay, so if you go to On Campus and you go to topics, it's that chapter P material. It'll be really obvious which one is which. So if you want to go look at that real quick, go for it. On your screen right now is some important notes. The only thing I missed on this were the logarithms and exponential notes, which I can add here in a second, but I'm hoping that we went over that fairly recently and quite a bit. So I'm hoping we don't really need to go over them explicitly like right on here, but I will put them up once we get to those problems. All right, so this, what you see on your screen, symmetry, lines, inverses, function notation, function combinations, and all that stuff, and transformations, as well as parent functions, which I also don't have up here. That's like the test. Okay, so this is a little bit of a patchwork test. There's just a lot of little things here or there that we need to know, and this is the only way to do it. Right, this is the only time we have to do that. So, have questions. If you have questions, put them into the chat or email me. It's probably easier to just put it where I can see it quickest. But I will occasionally check my email. All right. So I just need to find my stylus real quick, and once I do that, we'll start. So give me 2 seconds. All right. So I'm hoping we've had enough time to kind of look at this stuff. Again, I'll go through this as we go, but this is up here for you. All right. So chapter P test. This is just the preparation test for actual calculus. So we're not quite in calculus yet, but we're getting close. So 1, 2, 3, and 4 all have to do with lines. Lines are things that you guys have been working on for a very long time. Okay, we are using the equations, right? Slope between 2 points. That's the difference of the y's. Oops, that should be a 1 over the difference in x's. And then we have a couple of different equations of lines. We have slope intercept, and we have point slope. So we'll be using these to answer those questions. All right. Again, lines, they go up and over at a constant rate, which we'll talk a little bit more about once we get into actual calculus. So we should know what the graphs look like. We're not going to test graphs, but we do need to be able to write equations of lines. So write the equation of the line through the given point with the given slope. We have the point 5, 5. We can call that x1, y1. And we have slope 7/5, which is m. Okay? So the way I would do this, the easiest way to do this is to use point slope form, because we have a point and we have a slope. Right? So we would just do y minus 5, y minus y1 is equal to m 7/5 times x minus x1, which is 5. If we do that, that's done. That's it. That's all I'm asking for. Okay. If you did it using slope intercept form, right? So if you started with y equals mx plus b, we have an x and a y value. That's 5 and 5. So 5 should equal 7/5 times x, which is 5, plus b. So 5 is equal to 7 plus b. So b is equal to -2. And then we have our equation. So either of these will work. Yeah, it doesn't matter which one, as long as you have an equation of a line. I guess you could use standard form, but no one uses standard form, at least not for a very long time. So point slope and slope intercept form will work. Write an equation aligned through the given points. So in this case, I'm not giving you a slope. I'm just giving you 2 points. But this is the same thing, right? So we should always find slope first. So we have an x1, y1, and an x2, y2. So we do y2 minus y1 over x2 minus x1. That should be a 2. And that's going to equal to negative 1 over 3. And then we have a slope. Okay, so now we have a slope and we have points. So what I would do is use point slope form. So I'll just use x1, y1 because that's part of our equation, right? Y minus y1 is equal to m times x minus x1, right? We labeled an x1 and a y1, and now we have m. So all we're doing is we're inputting those things in. So y minus 4 is equal to our slope, negative 1/3, times x minus x1, which is negative 2. Then we can just simplify. And then this, this is an answer that is good. Yes, this is a different practice. So I took the practice test and I just hit modify and regenerate all, and this is what I got. Okay, I modified a couple things. I think I got rid of. Well, I didn't get rid of one calculator question. I'll do that tomorrow. And then I made a couple of problems a little bit easier to handle. Okay, so yes, this is a different one. I gave you the answer key to the practice test I gave you in class online, right? So that's in your email. This is just a regenerated copy of that. Unless I'm horribly mistaken, but this is what I was going to use for the test, so I don't think it is. Can you go over the last question again? Yeah. You're given slope, so you're given m, and you're given some point. So y minus y1 is equal to x minus x1 times our slope. That's pretty much it. Okay, you're just plugging into point slope form, which is very similar to what we just did down here. So I'm hoping this one answers that question. All right, there's another way you can do this. So I use point slope form on this. You could also use slope intercept form, right? So we still need slope, so this is still important. But we could plug into slope intercept form, right? So I could choose one of these points. I'll do this in a different color. We could choose one of these points. I'll choose x2, y2. It doesn't matter which. And I can plug that into y is equal to mx plus b, right? So 3, our y value could equal to negative 1/3 x, so 1 plus b. So we have 3 is equal to a negative 1/3 plus b. We'd add the 1/3 over. So 9/3 plus 1/3, that's 10/3 is equal to b. So we'd have y is equal to negative 1/3 x plus 10/3. Both red and blue are totally fine. Again, I think blue is a lot easier because you're just plugging stuff in and then leaving it. But it's up to you. If you feel really, really comfortable with slope intercept form, then do that. If you don't, I would use point slope form. Hi, Caleb. How are you? I was going to say I recognize that name. I just didn't remember who exactly it belonged to. All right. So that's the first two questions. The next two are just parallel and perpendicular, right? So parallel lines, I'll do this in red. Parallel lines have equal slope. Perpendicular lines in green have opposite reciprocal slope. Okay, so write the equation the line describes. So through -2, -2, parallel to y is equal to -1/3 x. I'm going to do all the parts. I'm going to do every single question. So just sit tight. So we have slope, right? We have our slope. That's -1/3 because we're looking for parallel. And we have a point. So again, I'm going to plug this into point slope form. So y minus -2 is equal to -1/3 x minus -2. So y plus 2 is equal to -1/3 x plus 2. Again, this form works. It's easier. It's way more straightforward. For the other one, yeah, that shows up. We have the slope for the original, but we're looking for perpendicular. So m is, all we're going to do is flip it, and we're going to make it negative. So it's going to be -2/1, so just 2. And it's going through 2, 2. So we have y minus 2 is equal to 2 times x minus 2. Again, that'll do. And if point slope form freaks you out, just go back to slope intercept form, plug in x and y and m, and then solve for b, and then plug that back into the equation. Okay, so that's the lines. Again, I'm hoping we can go through this pretty quick. Again, this is stuff that you've been working on for a couple of years now. So I want to go on to the next part. If you have questions, I'll go back at the end. But I'm hoping we don't. But if we do, no big deal. All right, so part 2, it says part 3, but that's fine. Don't worry about that. It's going to be the second part. This is function composition and combination. Okay, so all we're doing is we're adding and subtracting and multiplying and dividing functions with each other, and then we're going to compose them in number 4 and 5. Okay, so f plus g, this stuff is easy. This is just equal to f of x plus g of x. All right, f over g is just equal to f of x over g of x. Multiplication, same thing. So f of x times g of x. And then we'll save number 4 and 5 here for a second. All right, so number 1, we're just adding those two things together. So x squared plus 6x plus 9 plus x plus 3. All right, so f of x plus g of x. So we have x squared plus 7x plus 12. F over g of x, that is just x squared plus 6x plus 9 over x plus 3. Again, this looks fine, but we can actually factor the type into x plus 3 times x plus 3 over x plus 3, right? Right, so if we factor, we get that stuff. There are common factors here, so we can cross out one of the x plus 3's, and our answer is just x plus 3. Okay. The reason I'm putting this in here is because this is going to show up a whole lot in literally the next chapter. So the sooner we're able to see things that we can factor and cancel them out with things in the denominator or what have you, the better, right? So we can factor x squared plus 6x plus 9 into x plus 3 times x plus 3. And then because we're dividing by x plus 3, those things cancel in red. If we leave it unfactored, is that okay? I would like you to simplify as much as you can. Like I said, I think yesterday, I'm going to try and make it obvious that it's factorable. The one I gave on the practice test in class, I think was a little bit hard. It will look like the one I have right here. Okay, so I would like you to factor it. I'll just say up front, it's going to have to be factored. That's not like, this step right here isn't all of the points. Like if you get here, that's worth something. It's just not worth everything. All right. Then we need to multiply. So x squared plus 6x plus 9 times x plus 3. Okay. And this is just like long FOIL. All right. So we do x squared times x squared times 3, 6x times x, 6x times 3, and then 9 times x and 9 times 3. All right. So x squared times x, that's x cubed. X squared times 3 is 3x squared. 6x times x is 6x squared. 6x times 3 is 18x. 9 times x is 9x. And 9 times 3 is 27. So then if we just combine like terms, we get x cubed plus 9x squared plus 27x plus 27. And then so long as I did all that addition right, that would be our answer. Okay, Fog and Goff. I'm going to put this up here. Fog of x, right? That's the same thing as f of g of x, right? So g of x is the input of f, whereas gof of x, gof of x, is g of f of x, so f of x is the input, right? So f of g of x that is our input squared, so x plus 3 squared plus 6 times our input plus 9. Then we FOIL, distribute, and combine like terms. X plus 3 times x plus 3, just as a reminder. We FOIL that, right? X plus 3 squared is the same as this, so we have to FOIL. When we FOIL, we get x squared plus 6x plus 9. And then we distribute the 6, so plus another 6x plus 18, and then plus 9. So then we get x squared plus 12x, and then 18 plus 9 plus 9. That's just 18 plus 18, which is 36. So that's our answer. G of f of x is now, so I'm going to write this out so I see it. So g of x squared plus 6x plus 9. That's what I had, right? Yep. And g says to take our input and add 3. So this is just x squared plus 6x plus 9 and then plus 3. So we just get x squared plus 6x plus 12. Okay, I want to pause real quick and make sure we see this, and I'll just pause for a minute and make sure we don't have any questions. All right, so I'm guessing there's no questions from that. If there is, again, I can always go back. But I want to move on to the next part. Testing for symmetry. So up above, I did have it, but I want to write it again. So to test for x-axis symmetry, we need to see that we need to test if f of x is equal to negative f of x. For y-axis symmetry, we need to test that f of x is equal to f of negative x. And then for origin, basically both those have to be the same. But for origin, if you're just testing it specifically, we need f of x to equal negative f of negative x. Right, so that's what we're doing. We're just doing those things. All right, so for x-axis symmetry, all we're seeing is if this f of x is equal to negative 6 over x. Right, so we just plug the negative outside. This is not equal to 6 over x, therefore not x symmetric. Usually you're only going to get x symmetry if you have some kind of like x squared. Or like a square root. No, so not x squared, ignore that. It's more like a square root kind of a thing. But yeah, I hope that makes sense. Let's write this in terms of f of x, because I think that'll help. So this is the same thing as f of x is equal to 6 over x. And we need to see that if negative f of x, which is equal to negative 6 over x, we need to see if that's equal to f of x. This is not equal to 6 over x, therefore not x symmetric. Okay. For y-axis, we want to test that f of x equals f of negative x. Okay, so we need to see that 6 over negative x is equal to uh, 6 over x, but it's not, therefore not y symmetric. Couple of questions. Is completed practice test due in class? No, it is not. That is simply just for you. All right, that's purely for you to see what the test is like. Do you have to test for all three? Yeah, I'm going to ask you to test for all three. Okay, so it's not x symmetric, it's not y symmetric. The other thing we have to test for is origin. In origin symmetry, I should have labeled all these. Also learn how to spell. We need to test that to see if f of x is equal to negative f of negative x. So we need to see negative f of negative x, which will be equal to negative 6 over negative x. These negatives cancel, so we get 6 over x. Therefore, this is origin symmetric. Okay, so again, you're just testing these three things. As so long as we know how to use function notation, that should not be a problem. Right, negative f of x means you're just taking the entire output. Right, that's the output, and you're making it negative. For y-axis, you're just taking the entire input and you're making it negative. So the input in this case, negative x, that's the x in the denominator. That's the input. And you're testing to see if f of negative x equals f of x. And then you do the same thing, but both for symmetry. All right. 7 and 8, using a calculator, find the x-intercepts and the relative min and or maximum of the function. Unfortunately, I don't know how to type. I don't know how to get my calculator up on this screen like I do on my laptop at school. So we're not going to do that. Instead, I'm going to explain how to do it. For zeros, so for x-intercepts, you would graph it, right? So you would plug f of x into y1, you'd hit graph, and then you'd go to second, and then trace, then go to zeros, and then it's going to ask you a couple of questions. So it's going to ask you left bound. Left bound means you want to go to the left of the zero that you're trying to find. Then it's going to ask you right bound. You go to the right of the zero you're trying to find. And then guess, which just means go in between. So left, do that, right, in between, and then that'll show you the x-intercept. Okay, the same is kind of true for minimum and maximum. If you're trying to find a maximum, you go to second, trace, and then if you're trying to find the minimum, you find the minimum, right? So if it dips like this, that's a minimum. If it goes up like this, that's a maximum, right? So anywhere it crests or anywhere it dips, that's what we're trying to find, right? So instead, we would do min or max depending on what we're trying to find. And then the same is true. So left, right, in between. And if I need to go over that real quickly in the morning for some people or right before class starts, that's totally fine. But we've practiced this a lot, so I'm hoping we understand how to do it. Okay, so number 9. Number 9 says to evaluate the following and simplify completely. This is going to require a little bit of that function notation. So given f of x, we want to find this thing. So f of x plus h minus f of x all over h. And this is one of those questions where there's a lot of stuff going on, so we have to be attentive. But it's not hard. We just got to split it up into different parts. Okay, so first thing we need to do, we need to find f of x plus h, because that's one thing we don't have. So f of x plus h, right? X plus h is our new input. So this is going to be 2 times x plus h squared minus 4 times x plus h plus 3. We FOIL that x plus h squared, so we get 2 times x squared plus 2xh plus h squared. Can distribute the 4 and then add the 3. So we get 2x squared plus 4xh plus 2h squared minus 4x minus 4h plus 3. So this thing is f of x plus h. And we're going to take that and we're going to subtract f of x, right? So let's put it in to our entire formula. This is going to equal to the line that we just found up top. And then we're going to subtract our f of x, right? And if we're subtracting all that, we are subtracting 2x squared. We're subtracting negative 4x, so we're adding 4x. And we're subtracting positive 3. And all of this is going to be over h. And if you look there for a second, you would notice that there's a positive 2x squared and a negative 2x squared. There is a negative 4x and a positive 4x, and there's a positive 3 and a negative 3. So what we're left with is 4xh plus 2h squared minus 4h all over h. H is a common factor up top, so we can factor that out. And then we have a common factor of h and h in the numerator and denominator. So our answer is just 4x plus 2h minus 4. Again, we are going to come back to this formula a ton. So the more we're able to work with that, the better off we're going to be. So I want to pause there for a second again and make sure no one has any questions. Can I go back over minimum and maximum? Yes. Yeah, so X-intercepts are zeros, right? So this is, right, okay. This is hard to do without the actual calculator. So I'm expecting you to use a calculator for this. I'm not expecting you to do this algebraically because there's a couple reasons why you don't know how to do that yet. But a calculator can do it for you just fine. All right, so say for number 7, we want to find the x-intercepts. In order to do that, we'd go to y equals on our calculator. In y1, we would type in negative x squared minus 3x plus 4. Thanks, Lally. So we go to y equals, we type in that equation, we hit graph, and then you'll get some graph that looks something like this. I don't know the exact placement of it, but you'll get something like looks like this. Okay, we are looking for 3 points. We are looking for the x-intercepts. Right, so that's those 2 points, and we are looking for the maximum in this case, right? Because this graph only crests, it never dips, right? So we're only looking for that blue point right there. When we're on our graph, in order to find the x-intercepts, we're going to hit the second button and trace. So second calc, second, and then the button trace, either one. That's going to bring us to a menu that says 0, min, max, and a couple other things. I forgot what it was. But once we're on that menu, for the x-intercepts, we go to 0. Okay. And then it's going to ask us 3 questions. It's going to ask us left bound, right bound, and guess. For left bound, we just take our cursor and go to the left of this point. So we'd go like somewhere down here. For the right bound, we would take our cursor and go somewhere to the right and hit enter. And then we would go in between and hit enter. And once we do that, it's going to tell us the exact x-intercept. Hi, Jack Height. So once we do that, that's going to get us that x-intercept. So we have to do that twice in this case. So we hit second trace, we hit the 0 option, we take our cursor and go to the left, we hit enter, we take our cursor to the right, we hit enter, and we go somewhere in between and hit enter. And that'll tell us the x-intercept. The same exact thing is true for the minimum or maximum, right? Except in this case, when we hit second trace, we want the, in this case, maximum. And then we still do left bound, right bound, and in between. It's -4 equal to x. Um, I don't know. I'm not expecting you to do it algebraically. We can. You should be able to. So if we do negative, so this is x squared plus 3x minus 4. So that'd be plus 4 minus 1. So you should get negative 4, 0, and 1, 0. Right, so those would be the x-intercepts. Again, I'm not expecting you to do any algebra for this. I'm expecting you to go directly to your calculator, plug in those functions in, second trace, 0, left bound, right bound, in between. Next time I'll try and get a trial of that on my computer so I can actually show you. But right now I do not have that. Okay, so that's all part 2. Part 3, which says part 2, is kind of the last stuff we worked on. All right, so it's inverses, it's logarithms, and it's parent functions. Will you remind us how to do this during the test? I will remind you at the beginning. I'm not going to be like telling you exactly how to do it on a test because I feel like that's a little bit unfair. But let's go to logarithms. All right. So exponentials, when we are solving stuff that looks like number 1, we are trying to get something to the power of an exponent is equal to something to the power of an exponent, right? When we do that, we can use the one-to-one property and solve for these blanks. Okay, so for a number 1, okay, the common base, so we want to get a common base on both sides, so we have to ask ourselves, how do we write 32 as the same base of 16? So what's the common base between 16 and 32? In this case, the common base is 2. (32), we can write that as 2 to the 5th. 16 we can write as 2 to the 4th. And then we combine these, or really we don't even have to do that. But we would have 5 times negative 2x, that's negative 10x, is equal to 2 to the 4th. Okay, because we have it one of this, because we have 2 as a base on both sides, and that's it. The one-to-one property says we can cancel those out, and then we can just solve negative 10x is equal to 4. So x is equal to 4 over negative 10. I'm not worried about you simplifying. I just want you to be able to get to that answer. So that's number 1. So there's going to be one of those, right, where you have to find the common base and then use the one-to-one property. There's also going to be one like number 2 where you actually have to use a logarithm. Okay, so in this case, you could list operations on x, right? So I'll just show you that. I'm not expecting you to do it. But if we look at this entire equation and we look at x, we need to list the operations on it. So the first thing that happens to x is we add 7. The next thing that happens to x plus 7, right? So this gives us x plus 7. That x plus 7 is taken to the power of 6. So this is the exponent of 6. So this gives us 6 to the power of x plus 7. That is being multiplied by 2. I'm not expecting you to do this. I'm just trying to get us to think. That gives us 2 times 6 to the power of x plus 7. And then we subtract 3. In order to solve for x, what we have to do on both sides is we have to reverse that order and invert the operation. So we have to add 3, which gives us x plus 3. We have to divide by 2, which gives us x plus 3 over 2. Then we have to do the inverse of exponential of 6, right? So we have to do the inverse of 6 to the power of something. The inverse of that is log base 6, right? Logs undo exponents, exponents undo logs, right? So if we do that, this would be log 6 of x plus 3. These should all be 4s. I don't know why I keep doing that. Yeah. Could we just get 6 to the power of x plus 7 by itself and then solve in the same way that we did 1? That's exactly what you're doing. I'm just trying to show you like how that's going to look, right? Then once we take log base 6 on both sides, we would subtract 7. Whoops. Right, so this would be your answer. You're not. I'm not asking you to do that. What Elijah is saying is exactly right. We would just add 3 over, so we'd get 2 times 6 to the x plus 7 equals 7. We would divide by 2. Right, we need to get rid of the 6, so we have to take log base 6 on both sides. Log base 6 of 6 to the power of anything, that cancels out. So we have x plus 7 is equal to log 6 of 7 halves. We would subtract the 7 over, so we'd get x is equal to log 6 of 7 halves, and then plus 7. I kind of ran out of room over here. But we get the same answer here. So you're exactly right. I like to do this stuff because it can structure how you're thinking. But if you feel good doing what I just did up here, that's totally fine. If you don't feel comfortable with logarithms or exponentials for whatever reason, I would recommend you do that. You list operations on X, and then you're just undoing everything. And once you do that, you're going to get the answer. Okay, number 3, this is another 1-to-1. All right, so we have a log 9 on both sides, and it's just log 9. So if there was anything else on the left or the right side, we couldn't do this. But because it's log 9 of something equals log 9 of something else, we get the 1-to-1 property again, right? So if we have log of A is equal to log, let's say log like 5 of A is equal to log 5 of B, we can just say that A is equal to B, right? And that's exactly what we have on number 3. So we have 4x minus 7 is equal to 5x minus 9. We subtract 4x over and add 9, and we get our answer. I'm going to erase some of this because I want a little bit of room to talk about the next problem. So if you need that, just go rewind or something. Sorry. We went over rules of exponents in class, and that says that if we multiply something with the same base, right? So if we do a to the power of b times a to the power of c, we get a to the power of b plus c. Okay, the same is true for logarithms. So if we ever have the sum of 2 logs, then we get the product of their insides, right? So what that looks like, if we have log base a of b plus log base a of c, this is the same thing as log base a of b times c. Okay, so a sum of two logs means we're just multiplying the insides together. All right, so if we do that here, right, we have the sum of two logs. So we're just multiplying their insides. So log base 5 of x squared plus 36x is equal to log base 5 of 37. And this is one thing I'm going to change. I'm going to make this not a quadratic just to not confuse as many people. And once we do that, actually I might keep it because this one's pretty easy. Or if I do it, it should be relatively straightforward. Now we have just log base 5 on the left and just log base 5 on the right. There's nothing else outside. Okay, because we have that, we can cancel them out. That's the one-to-one property. And then we have x squared plus 36x plus 37 is equal to 37. Sorry. And then we can solve, right? If we subtract the 37 over, we have a quadratic, which we should know how to solve. What if the base is different? I will not give you something where the base is different. There are tricks that you can do to maneuver away from that, but sometimes it's pretty tricky and there's no reason to do it. So I will only give you stuff on like number 4 and 3 where the bases are the same. Yeah, so I wouldn't worry about that. All right. If we were to solve this, we get x plus 37, x minus 1 is equal to 0. So our answers are negative 37 and positive 1. Again, if I give you a quadratic like that, it should be pretty obvious of what to do. Bottom line, right? So the most of the points will be doing this piece where you multiply the insides together, and then realizing the one-to-one property where you can cancel those things out. Okay, that'll be most of the points. The rest will be a little bit of algebra. Number 5, so I'll try and keep that in view. I'll try and keep number 3 and 4 in view. Okay, number 5 is just asking you to evaluate. So what this is saying is it's saying 3 to what power is 1/9. Okay, and if you know your exponential rules, you know that 3 to the power of negative 2 is 1/9. So this whole thing is just equal to negative 2. While people are maybe looking at the top 2 or number 5, I just want to reiterate what the definition of a logger actually is. Okay, so if we have a to the power of x is equal to y, that's the same thing as saying log base a, right? A is our base of y is equal to x. Those things say the same. So a to some power is y, a to some power is y. You're just looking for that. They're just in different places. Could you just do number 5 in your calculator? You could, if you know how to maneuver it. If you want to log base on a calculator, you just go to math, and then I think you just scroll down, and then that should say log base. You can. I'm hoping that we understand this definition. That was kind of the point of this problem. But yeah, you can. Okay, I'm gonna scroll down now, so we have a little bit of room. Find the inverse of each function. So number 6, we're trying to find the inverse. All we have to do here, so I'm gonna rewrite this as y is equal to the cube root of x plus 3 minus 1. In order to find the inverse, the first thing we do is we swap the variables. If you remember back from class, did you combine the logs on the left on number 4? Yes, I combined the logs on the left on number 4. Okay, if we have a sum of 2 logs, right, that's up here. If we have the sum of two logs with the same base, we're just multiplying their insides. So that's where log base 5 of x squared plus 36x came from. Okay, so in order to find an inverse, the first thing we do is we swap variables, right? So I swapped x with y and y with x, and then all we're doing is we're solving for y. Okay, so we have to get y on its own. First thing we have to do there is to add 1. Whoops. I'm going to do that over here so I have more room. The first thing we do is add 1. So we have x plus 1 is equal to the cube root of y plus 3. We have to get rid of that cube root. So in order to undo a cube root, we cube things. So we have x plus 1 cubed is equal to y plus 3. And then we subtract 3. And this is our inverse. Okay, so swap variables, solve for y. To state if the given functions are inverses on number 7, we have to check to see that, in this case, g of f of n is just equal to n. Or we can also do f of g of n, which I'll probably do. Either one is going to look weird. I'll do g of f of n, right? So if we do g of f of n, we have the cube root of everything of f, so the cube root of n plus 2, and then minus 1. Okay, I can already tell you there's no way to simplify this. I mean, there kind of is, but it's decently hard. This is not equal to n. Therefore, not inverses. Okay, when g and f are inverses, things cancel out very, very well. That is not happening with this. Therefore, they are not inverses. That's not a very good explanation, but given these two things, we should see, like, in g, we have a cube root. So somewhere in f, we should see a cube. So that's one way to check. Okay. G also has a minus 1 on the outside, so there should be a plus 1 somewhere in the formula. Okay. Another way to check, right? The work I'm looking for, though, is this, right? You compose G and F, and you see if it's equal to N. How do we know to put the F in the G and not the vice versa? Both work. They're both the same thing. If you find G of F of N and F of G of N, they should tell you the same thing. All right, so if we compose F with G, or sorry, if we compose, F with G, we would still get something that looks kind of funky. We would get the cube root of N, which in this case is G, so the cube root of N minus 1, and then plus 2. Right, so this whole thing is G, and then plus 2 on the outside. Again, this doesn't cancel. We can cancel the negative 1 and positive 2, or combine them at least. But we still have this cube root of N. And there's no way to simplify all of this to just get N by itself. Okay, so both ways work. It doesn't matter. But that's how you do it. Okay. We're getting to the end. So you got a couple more problems. I want to write down these rules again, because I think it's been a while since we've seen them. Okay, so for a parent function, and there are 6 parent functions we got to know. So if you can't get N by itself, it's not an inverse. Exactly. Yeah, if you can't simplify F of G of N or G of F of N to just N, then they are not inverses. If they do cancel to n, then they absolutely are inverses. Okay, so I'm just writing down these rules again. There's 6 different parent functions. I'll go over to my notes because I have those drawn in my notes. So instead of drawing them again, I'll just put them up. But we have translations. Okay, so we have vertical translations. That's these two. For a vertical translation, we are just adding to the output or subtracting, right? If we add, we're going up. So we're just taking the entire parent function and we're scooting it up. If we're subtracting, we're just taking the entire parent function and we're scooting it down. To move a parent function left or right, we are taking away from the inside. Okay, so if we subtract some number on the inside, so if we subtract some number from the input, we're gonna take our function and move it right. If we add some constant to the parent to the input, we're gonna take our entire parent function and shift it left. Okay. We also did reflections. Okay, so if we make our entire output negative, this reflects it vertically. So it reflects it it reflects it vertically. It flips it upside down. I'll just say that. And if we make the input negative, that flips it left to right. Right, that flips it around the y-axis. Okay, and just using those rules, we should be able to get the transformations of pretty much every function. The only thing we didn't go over was stretches and shrinks, but that's not as important to what we're going to be doing. Okay, so number 8 and 9 says describe the transformations necessary to transform the graph of f of x into that of g of x. So all we're doing is we're describing these reflections. All right, so I'm going to try and use highlighters here so we see it. So in number 9, right, this is the parent function x cubed. As a reminder to what that looks like, it's the elongated s. Okay, the negative 1 on the inside, that means shift right 1. The negative on the outside means we're just flipping it upside down. And that's what I'm expecting. That's it. You're just describing what is happening to the parent function with those transformations. Okay, so f of x equals absolute value of x. Again, if we don't remember what that looks like, it's the v, right? And we're going to take this, and this plus 2 says we're just going to shift it left 2 units. This negative on the outside says flip it upside down. Okay, so our new function, this is g of x, would be upside down and shifted left 2. So it would look like this. Again, that's pretty much exactly what 10 and 11 are trying to ask us to do, right? So our parent function in number 10, that's absolute value of x. This positive 3 says to move it up 3. Right, so we're going to start right there. This negative x says to, so I'm going to do something. Our original graph is going to look like this. Okay, let me actually, our original graph actually looks like this. Okay. The +3 says to move it up 3 units. Okay. The negative on the inside, so now we're here, says to flip the direction. Right, so original, let's label this. And then our actual function, right? So this thing, this negative on the outside, says to flip that last one upside down. So our graph is actually going to be this in green. That doesn't show up very well, but that's the graph. Do we have to give a rough sketch of the graph or just the words? For 8 and 9, you just use the words. I was just trying to get ahead of myself. For number 10 and 11, you have to graph the function. All right. So parent function, I'm going to draw that. I'm going to draw a rough sketch. So that's x cubed. That'll look like this. Okay, that's our original function. This -2 says to shift it down 2 units. So that'll look like this. Hi, Andrew. And then the negative on the outside of that x cubed just says to flip that thing in green upside down. So the graph we're actually looking for is this in blue. And I know this is getting messy. I'm just trying to help people understand. But this is our answer. You do not have to draw all 3 of those graphs or all 4 of them like in number 10. In number 10, I'm looking for that thing in green. And number 11, I'm looking for that thing in blue. All right. Last 2 questions. All right. It says to identify the parent function and write the equation for the given parent function. All right. So number 12, the parent function is, let's scoot up, f of x is equal to x squared. Right. That's the parabola. And this parent function is shifted left 1 unit and down 3 units. So this is left 1 and down 3. So what we need is we need to add 1 to the input and then subtract 3 from the output. So then what this looks like is x plus 1 squared and then minus 3, and that's our function. Number 13, this is the absolute value function. Okay, this absolute value function is shifted right 3 units, and then it's flipped upside down. So right 3, upside down. So we need f of x minus 3, and then upside down means we just throw a negative out front. So that means we are taking negative absolute value of x minus 3. And then that's our answer. Okay, so I want to leave that there for a second. I might even, yeah, I'll leave that there for a second. And then if you have questions over those 2 or any other questions, put them in that chat. Okay. And then I'll kind of scroll through the entire thing. And then if there's no questions after that, we'll call it. Okay, so I'm going to mute myself for a minute. And if you have questions, just type them out. Can I do another inverse problem? Yes. Give me a second to look up a good one, though. Okay, it doesn't look like there's questions over those transformation problems, so I want to do one more inverse problem. And then we will, I'll scroll through the rest, and then we will call it. Okay, so on this example, we can do this, well, okay. Let's find an inverse first. So let's say I want to find the inverse of 2x cubed, whoops, minus 1. Hi, Aiden. How are you? So to find an inverse, what we do, I'm going to rewrite this first as y is equal to 2x cubed minus 1. Okay, y is the same thing as f of x, so we're not changing anything. And then in order to solve, in order to find an inverse, the first thing we do is we're going to swap variables. So we're going to change y to x and x to y. And then all we're doing is we're solving for y. Okay, so in order to solve for y, the first thing we have to do is we have to get rid of that negative 1. So we have to add 1 to both sides. So we're going to have x plus 1 is equal to 2y cubed. Then we have to divide both sides by 2. And then we have y cubed is equal to x plus 1 over 2. In order to undo a cube, we want to take a cube root. So if we take the cube root of both sides, we have the cube root of x plus 1 divided by 2. And that's going to be our inverse, right? So this is the inverse of f. Okay, so that's one type of problem where you're just finding the inverse. All right, so let's say instead of finding the inverse, all right, so this is finding an inverse. Instead of finding an inverse, let's say I want you to verify that f and g are inverses. Okay, and I'm going to give you that f of x is equal to 2x cubed minus 1, and I'm going to give you that g of x is equal to cube root of x plus 1 divided by 2. Okay, so this is what we just worked with, but I'm running out of examples, and my school laptop is dying, so I can't regenerate a bunch. So this will do though, right? So say I give you these two functions and I'm asking you to verify whether or not they are functions. Okay, keep in mind these two questions, these were just assume they're not the same. All right. In order to do this, what we do is we compose f of x with g of x, and we see what we can simplify to. So if we do that, we're going to have 2 times our input, which in this case is all of g of x, that should be a 2, and this entire thing is cubed, and then we're subtracting 1. Okay, so we're composing f and g to each other, and then we're just going to try and simplify. All right, now if you look at this, we have a cube root, and we have a cube. Those things undo one another. So then we're left with two, and then times x plus 1 divided by 2 minus 1. Right, so again, the cube root and the cube undo one another. Okay, then you should see that 2 times anything over 2, those cancel. And then we have x plus 1 minus 1. And again, you should see that this plus 1 and this minus 1 cancel each other, and you're just left with x. Okay, this means that f and g are inverses of each other. Okay, if it didn't simplify to just x, then they would not be inverses of one another. Okay, so I'm hoping that answers your question. Take a look at that, make sure it makes sense. I'll mute myself for a second and then ask if you have questions. Okay, it seems like that makes sense. I want to quickly kind of scroll through. And if you have any questions, let me know. If you don't, after the time I get through scrolling, so it probably should be like 8:36 or so, we'll call it then. All right, so I'm going to mute myself. I'm going to scroll through it. And as you have questions, please just let me know and I'll answer them. Number 9 on this part, how do I get the x squared plus 2xh plus h squared? Okay. When you factor, so you're looking at this to this. Okay. X plus h squared is equal to x plus h times x plus h. And then you have to FOIL. Okay. So x times x, that's equal to x squared. X times h, that's just xh. H times x, that's also xh. And h times h, that's h squared. So then we have x squared, we have 2xh's, and then we have h squared. So that's where that comes from. Okay. So we scrolled through, we went over every single question step by step, and then we did another inverse question. Okay. So I'm going to call it here. This is going on like 90 minutes. So if you have questions, I will try and be in my office, in my room, and available at 7:30. Okay. If I am not there right when you get there, don't panic. I'll be there within a couple minutes of that. Okay. If you do have questions, I can answer on email. You can try that. We can always take a couple of minutes at the beginning of class, and I'll take any questions you have. It won't be super long, but I can at least clear some things up. Okay. Your test is going to look exactly like this. I might take out one of the calculator questions, but that's about it. I think I changed everything I needed to change. All right. So thank you if you came and watched. This will be up at some point. I don't know when it actually uploads to YouTube, so if you do need to go over certain things or you need to hear me explain something, I would keep this open so you can kind of slide through it. Otherwise, I'm not sure exactly when it's going to actually upload. Okay, it should be immediately, but I don't necessarily know how it works. Okay, but this will be available to you soon. Okay, if not immediately, if you're just staying on the video. All right, so that's all I've got for you. Thank you for coming, and good luck tomorrow.